Hey, it's me, Steve, and welcome to the third episode of Geo-Files. I might actually break this one up into a couple episodes. My goal with these is to keep these between 30 minutes and an hour. I don't want to go over an hour per episode. But today, what I'm going to do is I am going to talk about an experiment and show you the experiment I actually ran yesterday. I had this huge above ground pool that came with this house when I bought it. It was an abomination. It was so nasty and disgusting it had to come down. Well, we got rid of it Saturday. It's Monday now. And we got $24 for it in scraps, so there's that. But the bottom was all sand, sand put down under the liner of the pool. Even though the soil here is very sandy, this was obviously put there to help soften so you didn't step on things like roots and rocks that might be in there. So I had I thought it was a brilliant idea to run a sand experiment to show how streams develop. And I'm going to show that to you, but first I need to show you something else. Oh, hi, Bela. Bela is here. She never comes visits us. In case you don't know, I actually have 5 cats. You've seen Blackie. You've seen Ezra, those are the 2 black males. You just saw Bela. There is a white cat named Catenatron. She doesn't come in here very often. Then there's a Russian blue named Lilith. She has one eye. She had it surgically removed. I call her One-Eyed Lily. You'll never see her because she actually likes living in the basement. It's bizarre. But anyway, I need to show you something about streams before I show you the experiment. And then after I show you the experiment, I'm going with something with the experiment, but I need to explain something first. Okay, most people who don't end up becoming scientists still have to study science in school. But the problem I have with just showing people basic science and like spitting stuff out at them is science is actually a way of thinking. It's not just memorization. And another thing too, if you're only exposed to science briefly, you're going to be shown what we call the textbook examples of stuff, okay? And there's really nothing wrong with that. The textbook example sets the stage for you to understand something, so when you learn about it more in depth and learn the variations and the cycles and what changes can happen, that at least you have that basal understanding to build up upon. So you're not just like, what? So I am going to show you a textbook example of how streams form. Now, see, the bad thing is if you don't pursue science and don't go beyond the basics, you're just going to be left in your head with these textbook examples. But I'm going to show you a textbook example of stream formation first, and then I'm going to show you how that varies and how we run into problems with our ideas and how we try to solve them scientifically. Because not everything fits neatly into a textbook or a model. Some things are a little harder to explain. Okay, now this would be, I'm going to draw profile pictures as if you're looking directly upstream or downstream, it doesn't matter. Like if you were looking upstream, these would be your hills. Then you get this, and then you have something shaped like this. Okay, so these are all looking up or downstream. It doesn't matter which one. Your river would be about right here. Let's say right here. And we'll just put this one right here. Actually, we'll put it closer to the center because it's more relevant for a textbook definition. Okay, now if you were looking at these in map view, like if you were in the air looking down, a V stream would be pretty much flowing straight. It doesn't, that arrows just tell you which way the stream is going. Remember, this is these three are profiles, these three are going to be map views. This would be a meandering stream. I didn't mean to make that such a sharp. Okay? This would be a stream that occupies a U-shaped valley, and these can vary. Most commonly, they'll be cross-braided, which means your net flows this way. Sometimes they'll meander. You might get cross streams coming in. And we're only going to deal with a certain type of stream called a dendritic pattern. If you don't know anything about streams, that's fine. But these are all dendritic patterns, or the basis for dendritic patterns. So, I mean, the U shape is a little different. Okay, now your V valley here. Now, I was always told this would be what would be a youthful stream. Okay, as a stream meanders through its valley, say it's flowing out this way, or not meanders, it's cutting down into a valley. Say this is mountains on either side of big hills. It doesn't matter. That the valley will become V-shaped as that stream flows, it down cuts. Okay, and that is true. Stream valleys will typically be V-cut if they haven't established their baseline. What's the baseline? A baseline is simply where the stream ultimately flows into. That's all that is. It's zero elevation, where usually it's the sea or the ocean, but it can be lakes, especially in glaciated areas. It does tend to be lakes. So if your stream has not cut down enough, say your baseline is a lake and it's down here, your stream is going to continue to cut down and form V after V after V until it hits this baseline. Then what's it going to do? Well, it's going to start to meander. Okay? Now, when a stream hits its baseline, it begins to, instead of eroding down, it erodes laterally and forms meanders. So basically what would happen to your straight stream here, and streams will meander on their own. They don't need obstructions to do this. It's just a natural tendency to do with changes in velocity of water. I mean, even if a stream is flowing straight, once it hits that baseline, say this side might be flowing, the water might be flowing a little faster because, you know, the valley's a little more open. Same thing here. But here it's moving a little slower on the opposite side. Okay, so what's that going to do? Well, it's going to cause the stream to want to start to do this. And meanders, so now your V shape is it's working towards this. Okay, and the meanders will continue, and they can often get closer to one another, like this here. I'm sorry, my blue marker's horrible. Okay, and eventually the stream will want to follow the path of least resistance, and it will eventually go this way, abandoning this old channel, and that will be an oxbow lake until it fills in with sediments. But even after it does this and establishes that shorter path, it will start immediately meandering again. Because remember, these will cut laterally once they've established their baseline. In this case, your baseline's right here, or pretty close to it. Okay? So this would be an old age stream. Now, when we say young age and old age, it doesn't have to do with the chronological age. It has to do with the development of meanders in the river or stream. Oh, by the way, quick note. What's the difference between a stream, a river, and a creek? Nothing. There's no difference. It's one person's creek is another person's stream. One person's stream's another person's river. It's a naming thing. So I may say river, stream, creek, and flip them back and forth. They all are, they also come to the same processes anyway, so it doesn't really matter. It's just a term. They're just terms or words. Okay, now over here, this U shape. This is different, okay?
because you may not even be at your baseline here. Your baseline may still be here, but your stream is still might meander a little. It might be relatively straight, okay? It might do the braided thing, and I'm going to really show you what I mean by braided stream patterns. It might do this. Why does it do that? Because U-shaped valleys are not cut by this present stream that's in them. U-shaped valleys are formed by glaciers. Glaciers carve out U-shaped valleys, and we see this in alpine glaciers all the time. And I'm mentioning this because it's important for the model I'm going to present in the experiment. Glaciers are fat and wide, so we'll use red for our glacier. So say our glacier, we have no stream here. Say we have some topography here, doesn't matter what it looks like. And we have a glacial tongue come in. Now, glacial ice moves a lot slower, and it's a lot wider than a river. So then your glacier starts pushing into this valley, and then it starts pushing in more. It's going to start altering this valley shape, okay? And as that glacier continues to get bigger, it's going to change the shape of that valley more and erode it out in a U shape. That's how we get U-shaped valleys. Okay, I'm going to now show you how a continental glacier, like what you would find in Greenland or Antarctica, moves across the surface of the landscape in cross-sectional view. Okay, so say this is your ground surface. You have a nice flat surface, all right? And you're standing wherever. This is a cross-section. This is not a profile. We're not looking up the glacier or down it. We're looking through the side of it, okay? And I'm going to use red again. Okay, so your glacier starts moving, coming in, and starts moving. We're just going to say south, because most continental glaciers in the northern hemisphere go that way. Now, glaciers do not erode like bulldozers. They don't plow through and just pile a bunch of shit in front of them, all right? They actually erode by plucking and abrading. So as that moves forward, it's going to pick up rocks and debris from the land surface. And we all love those pretty pictures of white glaciers with blue ice and streams flowing on top of them. Got bad news for you. Most glaciers are very dirty things, and they're full of debris. Rock, dirt, silt, clay, tree bits, grass bits, whatever might have been on the ground as it moved forward. Now, it's important to remember, even if a glacier retreats, the ice is always moving forward. Now, I'll explain this in a second, okay? So, your glacier is moving forward, and then it stops moving forward. Now, when I say moving forward, I mean the glacier physically has stopped advancing. The ice is still moving forward. This is because the source is way upslope somewhere, and it may still be snowing there. There may still be ice accumulation, and it's still going to want to come forward. So the ice may still be moving forward. The ice will be moving forward, even though your glacier has physically stopped advancing. So what happens here? Well, when this happens, all that lovely dirt and debris gets piled up here, and then it rolls downhill and directly from the front and starts to form. I'm going to get rid of those lines now because they're going to get in the way. What we call an end moraine. And as long as the glacier stays there, that debris will just pile up in front of the glacier, making the end moraine bigger and bigger, and it will be what we call glacial till or glacial diamictin. So now your glacier is stagnant, okay? When I say stagnant, I mean it's not physically retreating, but it's not physically advancing, but the ice is still flowing forward, okay? So now your glacier is going to retreat. Say your glacier, rapid melting, okay? Your glacier pulls back. Remember, your ice is still moving forward. As long as this glacier exists, the ice will always be moving forward. But say your glacier pulls back to right across here. And this end moraine, here we'll do a plan view. We'll say the end moraine, this is a map view. We'll say your glacier was like this. This is your end moraine right here, okay? But now in map view, your glacier sits somewhere up here. So it's still depositing end moraine here, but not here anymore. What happens a lot of times is you'll get a lake here. So you'll get a lake here. Well, how long is that lake gonna exist? Well, it's gonna exist until one of two things happen. This glacier moves back far enough and fast enough where it's either going to flow out past the end moraine, or if it stays there long enough, what's going to happen is the dam's going to break and it's just going to flood catastrophically out into the plain. Okay, you can't really see it there, but here, there, it's just going to catastrophically flood out. Okay. Now this is all important because I'm talking about glaciers and I'm talking about streams because the model, that the experiment that I ran is based on this concept. So I'm showing you this. And as you can see, even though initially I showed you textbook definitions, the V, the angle and the U shape, I'm already showing you stuff that isn't textbook. Okay, so without further ado, I'm going to insert some clips of the experiment that I ran yesterday, and then I'm going to talk about it.
It's July 9th, 2017, time's about 18:23, and we got this pull out that came with the house when I bought it, and it's got the sand underneath it, and I thought this would be a good opportunity to try an experiment before I start filling this in. I'm going to do a stream experiment. That's downslope. I tried to get the sand, as you can see I raked it and whatnot, tried to gently slope it up here. I don't want too much of a slope because what I'm going to do is I'm going to show you how streams form. First I'm going to do with slow moving water, and then I'm going to do a lot of water at once and see what kind of pattern we get. As you can see, I sprayed it a little bit so for some cohesiveness on the surface so the sand sticks together a little bit, but let's see how this turns out. Okay, that's my garden hose. It's at about 1/4 power. I may actually turn it down a little bit. I hope the water doesn't pond in the middle. I'm pretty sure I got the slope good, but let's see what kind of stream pattern we develop here. See, some of the little sand mounds I have are forming obstructions, and it's starting to meander. I'm going to pull this back a little bit. I might have this water flowing too fast, I think. I might want to turn it down to 1/8. Maybe it's not. Let's just see what it does. Okay, so you do see, even though this is, since it's sandy, there's still a lot of water power here, so you're getting kind of a fluvial wide valley up here, which is what you'd expect from a lot of power. But as it goes down, I'm hoping as it loses velocity and tries to go, it'll form a nice meander, but we'll see. Starting to pull, form a little lake right there. The ground is taking a lot more than I had hoped, but you can see it's already starting. As I did turn it down a little bit, and I thought it was too powerful. But you can see cut banks have formed as it tries to meander. It's still flowing kind of straight here, more fluvial. You're seeing you're getting more straight until it gets over here. But you have cut banks over here. You have point bars right here, just like you would on a natural stream. But I'm just going to keep it going, and hopefully a nice stream will develop. You can see a cutoff forming right here. So the stream meandered this way, and it couldn't go that way anymore. So now it's trying to form a cutoff right here. And this, if it does successfully cut off, will just become like an oxbow lake. We're starting to develop a well meandering stream pattern here. If you look further down that channel, that increased water pressure, and the stream was coming like this and going like this, so that reduced the velocity, but now that's forming this cutoff, it's trying to push that way too. So we'll see if this channel succeeds or that one does. And near the top, we have a new cut bank forming right there. The stream has abandoned its old meander. Now that would have been an oxbow lake for a while and then would have just filled in with sediments. But I mean, this is just a sand demonstration. There's no clay here or anything, so you're still going to get a little bit of fluvial, faster moving characteristics, but it is showing a nice meandering pattern. It is starting to do it. And it's even trying to see that's a new cut bank. It's trying to meander that way now, which is south. It's actually flowing from west to east right now. Net flow. The downstream, starting the pond, probably going to get a lake down there. We'll just see what happens. Okay, it's 1854 now. As it came down more towards the middle, I did scoop the sand out. I mean, it's probably going to form a lake here. This would be the stream's baseline. This is probably where it's going to end. I was hoping it would make it all the way to the edge of the sand, but I don't think it's going to. But you can see it's still developing. That cut bank became straight again near the source. That's looking west. Once it establishes, I'm going to turn the water flow down even more, maybe down to 1/10. And once it puddles up there, and that lake would be the baseline. Once streams get a baseline, it should meander. Like, that's what it should do. Like I said, there's no clay here to hold particles, but it should still do it. So we'll just wait to see that fills up as the lake, the baseline, just if this meander pattern changes. That cutoff it formed and abandoned this meander. You can see it's starting to meander here and starting another cut bank right here. It's meandering a little bit, trying to cut right there, and then another one right there as it goes. Yeah, that's going to form a baseline. That's going to become the lake, the baseline. 1837, and I've turned it down my hose about 10% of what its maximum can do since it established a baseline. But I'm going to let this go for a while. We'll see what meander pattern develops, and then I'm going to turn it up again a little bit as if a flood event occurred, and we'll see how it changes. But just so you know, that's it looking east zoomed out, just so you see. Since this is sand, and there's no cohesive clay particles to stick it together, even though we are getting a decent cool meander like I was hoping for, you still see braided stream patterns as if there was a lot of water really fast. Since I've turned it down, it's eased up a bit, but we'll see what kind of meander develops, and then it's time for flood stage. I turned it up just a hair. I'm not going to do flood stage yet because I wanted to show you. See, it's coming down, and it did meander this way, but it's formed another cutoff over here. So when it goes to flood stage, we'll see which one dominates. And there are natural streams actually that don't flow to a baseline per se, like a lake or an ocean. Some will. They just travel for so long that the ground keeps absorbing the water as it moves, and eventually it just disappears. Okay, I'm gonna start flood stage time. We'll see what happens to the stream pattern. I'm going to turn the hose up to about halfway. There we go. And as you can see, larger volume of water down there. It's trying to find another route. Now in a flood stage, you're going to have more fluvial braided deposits anyway, because the river's not, once it establishes its meander channel, it doesn't, if you get a lot of water fast, it's not going to be able to hold it in that channel. But we're not going to do the epic floods thing. That's yeah, this is just like maybe equivalent to a 500-year flood, but I just want to see how it changes. (1842), we're still in flood stage, and that abandoned original meander channel, it's starting to flood. It became part of the floodplain, and now that we are in flood stage, it's becoming full of water again, and we actually have it trying to move. It's still meandering. It still has a main channel. You can see it comes, the main channel comes down like this, back, forming another cut bank, which would be like a levee, and that levee, natural levee, just broke. Now, what was the baseline here, this lake, it's trying to push its way out. Since we were in flood stage, and that was the old lake, the old baseline, but now we're in flood stage, so the river has pushed past the lake and has started down cutting or back cutting again. When streams meander, that means they've got a baseline and they start cutting laterally. They don't erode down, but we no longer have a stable baseline, so we're eroding down again, and it's starting to erode back. And you can see a fan type deposit here under where my finger is. But I'm almost done with flood stage here, and I've also increased the velocity now that it no longer has a baseline. You can also see it has overflowed its banks. It broke that levee. It's trying to form a new meander channel. And this has actually happened to like the Mississippi during flood stages. But I'm gonna let it go for another minute or so. You see it get the swirling eddies. And then I'm going to stop it, let it drain so I can show you the features. And then it's gonna be epic flood time. Like when a glacial dam breaks and a glacial lake just releases all its water. But so we're getting a new baseline down here. All right, time to turn it off. All right, it's 1847. This would be akin to a drought. But we can see now the features that have formed. See, during the flood stage, we got more fluvial deposits again. You see features like these bowed out, like it came out and then formed what we call a fan. It was still trying to meander. And you see it reactivated this channel, which it had previously abandoned. And you got some overflow into your floodplain, and that was, you see the meandering streams will form in their valleys. You'll see the old cut banks. All right. And this one broke its levee, came down over here, and formed a nice alluvial fan deposit. Wait for that to subside and go down a little so I can show you better. But even though the stream is dead, what used to be the old lake, the old baseline, is now a lake again, and it's still there. It stopped flowing past there while we're in drought stage. Okay. So, but yeah, where it came down, you can see where the higher velocity is, because the higher velocity water is going to be cut lower. And you had to meander. And when you develop meanders, the stream is always at its highest velocity in the outside of the meander before it comes back. That's why it cuts in the cut bank, but deposit, that would be, that's your cut bank, but it deposits on the point bar.
because the stream velocity is lower. Even though we had water running over there, it really wasn't eroding much. But it was eroding here, and it was cutting laterally until we hit flood stage. Then it started just spreading out because of water. There was too much water for the river channel to handle. So it tried to adapt, and it started flowing this way. We had that alluvial fan there. That would have kept developing, and it looks like it would have choked off this old meander. So the meander would have actually moved south a little. But now our lake is draining. So I'm going to scan over this really quick from east to west where our source was, and then I'm going to set the stage for catastrophic flood. Okay, it's 1855. I've got about 22 gallons of here, which are going to help me by catastrophic outflow. Like, say our stream was a nice meandering stream, and it was at the front of a glacier that was melting slowly. The glacier backed up, left a moraine, so it stopped flowing. You get this. But now that morainal dam is about to break. I added some ridges. I didn't mess with the original channel, but I did add some ridges to see how they are going to stand up to catastrophic flood. And I'm going to use these 22 gallons. I'm just going to kick them over in conjunction with the massive one. So first we'll start as if we've got the beginning of a catastrophic break. Now we're going to kick over the 5. The other 5. The 2. Now we're gonna do the big one. Wow, look at that. It destroyed everything. And the flood waters, the catastrophic flood part recedes. Our original channel is unrecognizable. Some of the high areas stood, served as a barrier. Some didn't. So now we're gonna get lakes off to the side. But now our stream is still flowing at high velocity. It's a residual meltwater, if you will. But the stream is trying to reestablish its original course. But look how broad that valley is now. It's huge. There's no real clear channel. You got one trying to go this way, one trying to go this way. The original path. And this is a new path. So I'm going to turn it down now. See, you got these side lakes forming. So you get a lot of braided ribbon deposits. You don't get nice meandering streams. You see, you get a lot of braidedness, and the valley's so wide when you get a catastrophic flood. I'm going to turn it down and see if it'll establish a nice bait line. I'm probably going to turn it down to about a quarter. I've turned it down about a quarter. It's 1859. So it's still flowing kind of quickly. I'll turn it down some more, but I wanted to see if it will form a meandering pattern again, or how long that's going to take. And now you've got a battle from the floods. You've got two dominant stream channels, and our little lakes are gone now. Volume of water has gone down, but we got a new lake over here. I just want to see which one's going to actually win out. Okay, it's 1903. I've turned it down to about a 10% power. It might be between 10 and 20. But as we can see, now that the flooding is gone and our stream, normal stream, has tried to reestablish itself, what you see is it's totally abandoned its original channel. Now we've got a lake again, which was the original baseline, but now it's trying to go this way. And there's new lakes forming. It's reestablishing meandering patterns again. And you can see how fluvial this is, how braided this is. We had a vague channel going down the original one again, barely hitting and starting to cut, but we still had even though the flood was over, it still affected this meander pattern that we had established in a well-established stream. And since we have all these braided ribbon type deposits from the flood, it was having trouble picking one. And so, like I said, our original lake is now a lake again, but there's no stream running into it, so it's just going to dry up. But we have a new meander pattern, no longer going, the original was going east-southeast. This is going northeast over here. And see, it's meandering again. It is trying to decide whether it wants this channel or this one. But you can see cut banks right there. I might turn the water down a hair more so it'll actually pick one. And we're getting still a braided type pattern right here as stream is straight. So it's still attempting to down cut. Okay, and now see how it's breaking off when it was in the flood river stage where the old lakes were? It's trying to go that way again. So we'll see what happens. We turn the river down and get it more like a stable river type velocity. Okay, it's 1911. I'm going to end this experiment soon, but I've had this running about maybe an eighth the maximum that the hose will put out. And as you can see, it's still trying to decide whether it wants to meander, but this channel here is becoming the dominant one. And it's still having a difficult time. See how it broadens? I mean, it's still having a difficult time establishing a hard meander, but I mean, we do have this. This is the old lakes that when the flood came out, you can see the light colored areas where the water pooled and you had the lakes. But you can see it's still having a hard time really meandering, but it's starting to. I mean, you can see you got this cut bank. There's a cut bank here, even though it's still trying to trickle that way. And you got a cut bank. Well, you got an old cut bank right here, and here's your point bar. It's in that line I just drew. But now the cut bank's over here, so it is trying to meander. You got a cut bank over there, and then this new forming lake is its baseline. But it's still down cutting a little bit. You can tell, not that much though, but that lake is essentially right there, its baseline. But what you can tell from this, and what I want you to get out of this, is when we had that flood event, all these really light colored areas, remember those are lakes, that was the original baseline of the lake for the stream when it was flowing east-southeast. That channel is gone. It's gone. You can see some faint traces of where a meandering stream once was, but it decimated its original channel. It's just abandoned it totally, went a total different direction. I mean, the flood there wasn't too much that survived the flood, the high areas I made. You got these ones survived, this one survived, this one survived, but there was a high area in this meander here, and it just went. Once the flood the catastrophic pump out of water, basically what happened was it tried to find a course, a stable course, but the water just fanned out. It just fanned out until it could try to find a stable course. And once the water subsided and stopped coming at such a hard velocity, and well, first of all, when it is that hard and fast of a velocity, you get all these braided stream patterns. Which means you get channels, fingers, if you will, that cross over and over and over. You have them over here too, and down there too. So the water can't establish an exact course until the flood retreats, and then you get a baseline, and then the stream can start to meander again, like it's trying to do now. But it's going a totally different direction than it originally was. And that's important because when you have a catastrophic flood event like a glacial dam breaking, it changes the landscape. You don't get nice meandering streams until the floodwater retreats, and if you still have precipitation, and like in this case we have a typical stream, we'll just say it was a highland stream, that kept flowing like it originally was a glacial front stream, in this model that we had presented. So the glacier was out front here, it was melting, a nice meandering stream. The glacier pulled back, had dropped a dam,
of deposits in end moraine, which glaciers are known to do. This has been observed time and time again. And what happened was then the channel dried out, wasn't being fed, then that moraine broke. And basically it just went boom, the water, trying to find a new course, decimating the old channel. We had a lake in the old lake for a while. And now you got to reestablish normal stream. Glacier's long gone, flood's long gone, but it's trying to reestablish a nice meandering channel. But some other features you can see is you can see the lakes where the lakes were. You can see the deposits, the debris at the flood, just kind of in the highest area of the velocity of the flood, which was near the break. Everything just got washed down. Then it hit that old lake and started dropping debris right there, just right in that lake. And you got the lakes over here, same thing, sort of pushing, but you can see just the fingering braided stream patterns. Even towards the lake, you got this the original lake. Okay, I could wrap this up. It's getting late, and plus my water bill's going to be through the roof. But even like the old lake bed where it just dropped debris, because when the stream comes down and hits a lake bed, it just loses velocity and drops its load. That's why you see almost no debris here and a ton here. But you can see the alluvial fans that tried to form, even those two rocks. Okay, it's 1955 and the experiment is long over. I'm looking due east right now. I'm just going to show you the end effects, and I'm going to get down lower so you can see some of the topography and some of the features that form. This is near the headwaters. Just pan that way. It's northeast, and that's southeast. So, sum up real quick. We initially had a established stream, started to flow meanders, then the stream got choked off. We had a lake form for a baseline right there. The stream got choked off and dried up. The lake stayed for a while, and then we had a flood stage. Not an epic flood stage, but something enough where the river channel the water started to spread out into the floodplain. It reactivated an old channel. Spread out into the floodplain, tried to adapt, even broke a levee, ended up pushing further downstream past its baseline to establish another one in another lake down there. And then what happened was we had an epic flood, just a huge flood, as if a glacial dam broke and just released a torrent of water. What that did is it decimated the old plain, pretty much cleaned out the channel full of debris and dropped it in the old lake bed, because the stream can only carry so much stuff so fast. As long as it's moving quickly, it can carry bigger objects, but as soon as the velocity stops, it's just going to drop its load. And that's what happened, and it totally abandoned that old channel. Originally we just had water going everywhere, trying to figure out where to go, and eventually it decided it was going to flow in this northeast channel and form another baseline at another lake. So what we learned is that well-established meandering streams like to stay in their valley. When streams hit a baseline, they no longer erode down, they start eroding laterally. And even during a flood event, they'll still kind of do that unless the baseline gets destroyed and they have to establish a new baseline, and they'll start to downcut again. But once that baseline's established like that, but you get a catastrophic flood event, all bets are off. And you can end up with a totally new landscape. But it just that old meander channel was gone. I mean, it was still physically there. You can still see it, but it's no longer a stream. The valley had widened. It couldn't continue down that path. It established new lakes, and then once the floodwater subsided and we got a more normal stream velocity, the stream totally went a different direction. So yeah, that's basically what I hope you got from that.